Let us begin by discussing how the WWC assesses compositional change in individual-level randomized controlled trials. The image on this slide summarizes the framework used for determining WWC research ratings for findings from individual-level RCTs. As shown here, the WWC assesses compositional change in individual-level RCTs by assessing the sample attrition in the design. Attrition refers to the loss of participants from a research study after random assignment to conditions. Individual-level RCTs with low attrition are eligible to receive the research rating meets WWC standards without reservations, whereas those with high attrition are only eligible to receive the research rating meets WWC standards with reservations, if the study also satisfies the baseline equivalence standard. For high attrition RCTs, the choice of attrition boundaries, which we will describe later, does affect the available options for satisfying the baseline equivalence standard. So what is attrition? Attrition is the loss of study units, such as students or teachers, from a sample. It occurs when a study's analyses do not include a sample member who was randomly assigned as part of the study. Within a study, attrition rates may vary across time periods, data sources, and even different outcomes. The image here shows a study sample at random assignment and follow-up. The boxes on the left illustrate the full sample of 48 randomly assigned individuals, 24 in the intervention group and 24 in the comparison group. By the time of the first follow-up, only a subset of those 48 individuals remain in the study. The boxes on the right show that the study observes outcome data for only 13 individuals in the intervention group and 14 individuals in the comparison group at follow-up. So what causes attrition? There are many reasons why a study may not include data for a sample member who went through random assignment at the beginning of the study. Here, we discuss several causes of attrition, although this is certainly not an exhaustive list. For example, parents may not consent to their child's participation in the study. Students may move and transfer to a school that isn't participating in the study, or students may be absent when the study researchers collect data. Other causes of attrition might include a student's refusal to participate in the study, an inability to locate students who are enrolled in the study, students dropping out of the study, and inconsistent or missing data. Non-participation is another issue to consider related to attrition. Non-participation occurs when an individual assigned to an intervention condition does not participate in the intervention. For example, students might leave an intervention classroom, or they might refuse to participate in the intervention. Sometimes researchers still observe outcomes for these non-participating students. If the individuals assigned to the intervention do not participate, it may decrease the study's likelihood of finding an impact of the intervention. However, non-participation does not introduce bias as long as the researchers still collect outcome data from the non-participants and analyze them according to their assigned conditions. If the study collects outcome data from non-participants and includes the students in the analysis according to their originally assigned conditions, then non-participation does not count as attrition. The WWC will count non-participation as attrition, however, if the study does not collect outcome data from non-participants. As described previously, studies must analyze individuals according to the condition to which they were initially assigned. Sometimes researchers will treat an intervention group student who did not receive the intervention as if they belonged to the comparison group. If a study changes the condition of any student in this way, then it compromises the integrity of the random assignment, and the WWC would consider this a compromised RCT. The highest possible rating findings from a compromised RCT could receive is meets WWC standards with reservations. We'll talk more about studies like this in the next module. Why does the WWC care about attrition in RCTs? Recall that one of the primary benefits of an RCT is that random assignment of units to conditions helps ensure that the intervention and comparison groups should be similar, on average, in terms of both observed and unobserved characteristics. However, when attrition occurs in an RCT, the groups can become dissimilar, which can lead to bias in the estimated effect or impact of the intervention. Bias is a systematic difference between the true impact of the intervention and the estimated impact. So bias can lead to incorrect conclusions about the effect of the intervention. Suppose an intervention actually has no effect on students' test scores, so the true impact is 0. However, it may appear that the intervention had a positive impact because of the students who remain in the groups after attrition. For example, imagine that the 6 individuals in each intervention condition shown in red in this illustration always score higher than all of the other individuals. There are equal numbers of red individuals in the intervention and comparison groups at random assignment, but at follow-up, the study experiences some attrition. Now, because there are more red individuals in the intervention group than in the comparison group on average, the intervention group has higher test scores at follow-up than the comparison group. As a result, the intervention may appear to have an impact when it did not, simply because of attrition. So, attrition can result in a systematic bias if something other than the intervention is causing the difference between the groups in the study. When assessing attrition in individual-level RCTs, the WWC focuses on 2 different types of attrition: overall attrition and differential attrition. Overall attrition is the percentage of randomly assigned units for which the researchers do not observe outcome data. You can think of overall attrition as the level of attrition for the whole sample. For example, the overall attrition rate would be 25% in a study if 75% of the originally assigned sample members remained in the study. But sometimes studies have more attrition in one group than in the other group. Differential attrition is the absolute value of the percentage point difference between attrition rates for the intervention group and the comparison group. You can think of differential attrition as the level of attrition for the intervention group minus the level of attrition for the comparison group. So for example, if 35% of the individuals in the intervention group dropped out of the study and 15% of the individuals in the comparison group dropped out, the differential attrition rate would be 20 percentage points, which is 35 minus 15. When assessing attrition in individual-level RCTs, both overall and differential attrition are important. Let's take a closer look at how the WWC calculates overall and differential attrition and walk through an example. Imagine a research team randomly assigns 1,000 students to the intervention group and 1,100 students to the comparison group. The team collects post-test data from 900 intervention students and 927 comparison students. Using this information, we can calculate overall attrition, attrition for the intervention group, attrition for the comparison group, and the differential attrition. First, let's organize the numbers in the example. For the intervention group, we know that there are 1,000 students in the group and the researchers collected post-test data for 900 of them. For the comparison group, we know that there are 1,100 students in the group and the researchers collected post-test data for 927 of them. The total sample size at the time of random assignment is therefore 2,100 students. This includes the 1,000 intervention group students plus the 1,100 comparison group students. The total number of students with observed post-test data is 1,827. This includes the 900 intervention group students plus the 927 comparison group students. To calculate overall attrition, we will need 2 quantities: the total size of the randomly assigned sample and the total number of sample members with observed data. We then take the difference of these 2 totals to calculate the total number of students without observed data. So, looking at our example, we know we started with 2,100 randomly assigned students. The researchers observed outcome data for 1,827 students. The difference between these two numbers is 273, meaning the researchers did not observe outcome data for 273 students. The loss of 273 students from the 2,100 randomly assigned students represents attrition. We divide 273 by 2,100 and get 13%. So, 13% is our overall attrition rate. The WWC takes a similar approach for differential attrition, but conducts the calculation for each group. For the intervention group, we started with 1,000 randomly assigned students. The researchers observed data for only 900 students, so they didn't observe data for 100 students out of 1,000. The attrition rate for the intervention group is therefore 10%. For the comparison group, 173 of the 1,100 randomly assigned students lack observed data. This results in a 15.7% attrition rate for the comparison group. So, to calculate differential attrition, we take the absolute value of the difference between the two attrition rates. We get 5.7 percentage points as our differential attrition rate. Later in this module, we will discuss how to apply the WWC attrition standard to determine whether the amount of attrition in the study is large enough to affect the study findings' research rating. The purpose of the WWC attrition standard is to limit the amount of bias that could result from attrition in an RCT that receives the highest WWC research rating. The WWC attrition standard is based on a model of attrition bias. The attrition model drew on data from several large education studies and considers different combinations of overall and differential attrition, estimating how much bias is expected for each combination. The WWC chose 0.05 standard deviations as the boundary for an acceptable or tolerable level of bias resulting from attrition. So, if the model suggests that the study's expected attrition bias is greater than or equal to 0.05 standard deviations in absolute value, the WWC defines that as high attrition. This is not a tolerable amount of bias. The chance that attrition, rather than the intervention alone, could be responsible for the measured differences in outcomes is too high. As a result, RCTs with high sample attrition must either demonstrate baseline equivalence between the intervention and comparison groups or control for relevant characteristics depending on the attrition boundary. The baseline equivalence module, which is the next module in the training series, discusses the baseline equivalence standard. If the WWC attrition model indicates expected bias of less than 0.05 standard deviations in absolute value, the WWC defines that as low attrition. That is, the study has a tolerable amount of bias. We can be reasonably confident that the impact estimate reflects the true impact of the intervention. This is why findings from individual level RCTs with low sample attrition can receive the highest possible WWC research rating of meets WWC standards without reservations. We have a matching game to help you practice what you've learned. In this game, you will match a term in the left column with a phrase in the right column. The first term listed in the left column is attrition. The choices are A. The percentage of randomly assigned individuals who do not have outcome data. B. Systematic error in an estimate due to loss of sample. C. When an analysis does not include an outcome from an individual randomly assigned in the study. Or D, the difference between intervention and comparison group attrition. Which phrase matches the term attrition? Feel free to pause the video at this point so you can read through the answer choices first. The correct answer is C, when an analysis does not include an outcome from an individual who was randomly assigned in the study. The second term listed in the left column is overall attrition. The remaining choices are A, the percentage of randomly assigned individuals who do not have outcome data, B, systematic error in an estimate due to loss of sample, or D, the difference between intervention and comparison group attrition. What choice does it match to? The correct answer is A, the percentage of randomly assigned individuals who do not have outcome data. Finally, what phrase does the term differential attrition match to? The remaining choices are B, systematic error in an estimate due to loss of sample, or D, the difference between intervention and comparison group attrition. The correct answer is D, the difference between intervention and comparison group attrition. Now that we have discussed how to calculate attrition in individual level RCTs, there are a few additional considerations to keep in mind when calculating attrition. Often, missing data are an issue when conducting research. When a study is missing outcome data, researchers may impute data by replacing the unobserved data in some way. For example, study authors may use a technique called multiple imputation to predict missing values, or they may replace missing values based on other models. In the WWC Procedures and Standards Handbook, the WWC specifies several acceptable ways to impute data. Methodological research suggests that imputation, like attrition, may introduce bias into study findings. For this reason, when calculating attrition in a study, the WWC always will consider imputed outcome data to be attrition. Remember that RCTs have the potential to receive the WWC's highest research rating because we can be confident that the groups created by random assignment were similar at the time of random assignment, and the differences in outcomes between the groups are due to the intervention. Imputed data can lower our confidence that the difference in outcomes between the intervention and comparison groups are due only to the intervention, and not due to how the study imputed the data. To address these concerns, when an RCT reports on analyses based on imputed outcome data, the WWC will consider the imputed data to be missing when computing attrition. For example, imagine a study analyzed data from 100 students. Those 100 students include 90 students who were present during the post-test data collection, and thus they have measured outcome data. But the 100 students also includes 10 students who were absent on the day of post-test data collection, so they did not have measured outcome data. So instead, the researchers used an imputation method to impute the missing data for those 10 students. In this example, the WWC would count those 10 students with imputed outcome data to be attrition. Later modules in this training series provide additional detail on the WWC's procedures and standards for reviewing evidence from analyses with imputation for missing data. Another issue to consider is that researchers conducting RCTs sometimes exclude units from their analysis. If doing this creates differences between the intervention and comparison groups, it could introduce bias. However, in some instances, sample exclusions in RCTs after random assignment do not constitute attrition. The first scenario where sample exclusions do not count as attrition are sample exclusions due to acts of nature, if both conditions are affected. Loss of sample members after random assignment because of acts of nature, such as hurricanes, earthquakes, or pandemics, is not considered attrition when that loss is likely to affect both the intervention and comparison group members in the same manner. However, if the sample loss caused by an act of nature was concentrated in only one group, the loss will be considered attrition. The second scenario, where sample exclusions do not count as attrition, are when those exclusions are based on random selection. For instance, imagine a scenario where authors recruited 1,000 students to be included in a study and randomized them into the intervention and comparison groups. After randomization, the authors realize that they can't afford to study all 1,000 students. Instead, they randomly select a subsample of 500 students to include in their final analytic sample. The 500 students that were dropped from the final analytic sample randomly do not count as attrition. And the third scenario, where sample exclusions do not count as attrition, are when those exclusions are based on characteristics determined prior to the introduction of the intervention, and they are applied consistently across groups. For example, if students were excluded from data analysis because they had individualized education plans prior to the study, this would not be counted as attrition if they were excluded from both conditions. The WWC considers characteristics that are unlikely to change over time, such as sex and race or ethnicity, to be determined prior to the introduction of the intervention, even when the researchers may have collected these data later in the study. Beyond these three scenarios, the WWC otherwise presumes that sample exclusions arising from other sources could be related to outcomes and therefore could constitute attrition. Time for our first knowledge check in this module. Which of the following is not a cause of attrition? A. Researchers collected parent permission forms after random assignment. Some parents did not want their child to participate in the study. B. Thomas had permission from their parents to participate in the study, but they refused to complete the assessment. C. Alondra took the pretest, participated in the intervention, but then dropped out of the study. D. Juanita did not consent to the study before random assignment, so the authors did not collect outcome data from them. You may want to pause the video here to think about your answer. The correct answer is D. This scenario is not a cause of attrition. Juanita did not consent to the study before random assignment, so the authors did not collect outcome data from them. Juanita never consented to participate, so the authors never randomly assigned them to a condition. Non-consent before randomization is not a cause of attrition, because attrition includes only individuals who went through random assignment. However, non-consent after randomization is a cause of attrition. Often, some parents do not want their child to participate in a research study, but non-consent after random assignment is considered attrition. Non-participation, as in the case of Thomas, is indeed a cause of attrition. And finally, if a student drops out of the study before completing the post-test assessment, then the WWC also considers that attrition. Knowledge check 2. Which of the following is not a cause of attrition? A. Ricky, Elena, and Sam were absent on the day of outcome data collection. B. Jose was not listed on the class roster that was used to randomly assign students, so they were not randomized to a condition. Because of this, the researchers did not collect outcome data from Jose. C. Researchers could not locate Jim, Juan, and LaShawn because they did not attempt to track and collect data from students who moved or dropped out of school. D. Researchers used school records to construct study outcomes, and the records were incomplete. You may want to pause the video to think about your answer. The correct answer is B. A participant must be randomly assigned to be counted as attrition. When students are absent on the day of data collection, researchers cannot collect outcome data for those students, which counts as attrition. Students changing schools or dropping out of school is another common cause of attrition. And finally, missing outcome data from incomplete student records is also considered attrition. Now let's turn to the attrition boundaries established by the WWC. As mentioned before, the WWC has established an attrition model that identifies the expected bias for each combination of overall and differential attrition, which then separates what the WWC defines as high and low attrition. The WWC uses this model to define two boundaries for attrition, an optimistic boundary and a cautious boundary. Teams conducting WWC reviews are responsible for determining whether to use the optimistic or cautious assumptions when assessing sample attrition, and will document this reasoning in the study review guide. In general, choice of the optimistic boundary indicates that the review team has determined that attrition in a sample is unlikely to be related to the intervention. Examples where the optimistic attrition boundary could be used include interventions that are unlikely to influence retention in schools, such as supplemental K-12 curricular or other targeted interventions delivered during regular school hours. The cautious boundary, on the other hand, will be appropriate in scenarios where the review team believes the attrition in the sample is likely related to the intervention. For example, the cautious boundary typically should be used when reviewing dropout prevention programs, school choice programs, programs delivered outside of regular school hours, elective or selective courses such as advanced placement courses, and post-secondary interventions that could affect student course or college enrollment decisions. If a review team finds that they cannot defensibly choose between the optimistic and cautious assumptions, they should articulate this and should use the cautious assumptions. The graph on this slide illustrates the difference between the optimistic and cautious attrition boundaries. The vertical axis on the graph represents differential attrition, and the horizontal axis represents overall attrition. When the combination of overall and differential attrition rates falls in the green area on the graph, this means that there is low attrition. When the combination of overall and differential attrition rates falls in the red area on the graph, this means that there is high attrition. The yellow area of the graph, then, is where findings will be deemed to be either high or low attrition, depending on whether the optimistic or cautious boundary is used. Under the optimistic boundary, the WWC considers attrition that falls in the yellow area to be low attrition. But under the cautious boundary, the WWC considers attrition that falls in the yellow area to be high attrition. For instance, the black dot on the graph represents a study with 15% overall attrition and 10 percentage points of differential attrition. If the WWC were reviewing the study under the optimistic boundary, the study will have low attrition because it falls within the yellow area, and we are operating under optimistic assumptions. Conversely, if the WWC reviewed this study under the cautious boundary, the study will have high attrition because it falls within the yellow area, and we are operating under cautious assumptions. Remember, the WWC review team selects the attrition boundary prior to reviewing any studies. Again, WWC review teams should select the optimistic boundary when they believe that the types of interventions studied are unlikely to affect attrition. For example, if researchers are implementing a reading intervention during regular school hours, the optimistic boundary may be appropriate if it seems unlikely that the reading intervention would directly affect the probability that students will leave the study. For example, families probably won't decide to move simply because their child's school is using a certain reading instructional strategy. The expected bias due to attrition is lower in situations like this, so more attrition is acceptable. Conversely, review teams should choose the cautious boundary when the types of interventions being studied are more likely to affect attrition. For example, suppose researchers are examining an intervention designed to improve algebra success. High school students often can choose classes on their schedule, including whether or not to take an algebra course. So a student could choose to leave a class because of the intervention. This type of attrition has the potential to lead to bias. Dropout prevention programs are another good example. Attrition in studies of dropout prevention interventions may be linked to what the interventions are trying to affect: dropping out of school. Students who drop out may be more difficult to track or less likely to respond in data collection efforts, which means high rates of missing data may yield a skewed measure of the difference in dropout rates between the intervention and comparison groups. In this case, the review team should select the cautious boundary because the expected bias caused by attrition is higher. The WWC has several resources available related to these attrition assessments. The handbook includes a table with the maximum allowable differential attrition for any given level of overall attrition under the optimistic and cautious assumptions. The Online Study Review Guide, or OSRG, a tool that WWC reviewers use to conduct study reviews, provides reviewers with quick and easy tools for calculating attrition rates using built-in formulas. After entering initial and follow-up sample sizes into the OSRG, the tool calculates and assesses attrition for reviewers. The OSRG is the subject of Module 12 in this training series. Finally, to learn more about the WWC attrition model, you can review the WWC white paper on Assessing Attrition Bias, which is available on the WWC website. Circling back to the example we discussed earlier, remember that we calculated overall attrition in this example at 13% and differential attrition at 5.7 percentage points. So how would we determine whether this is considered low attrition under the cautious boundary? And how would we determine whether this is low attrition under the optimistic boundary? Let's consult the handbook to find out. The table shown here is an excerpt from a table in the handbook, which lists the highest differential attrition rate for a sample to maintain low attrition by overall attrition rate under the cautious and optimistic boundary assumptions. The table lists the overall attrition in the leftmost column. Again, recall that the overall attrition from our example was 13%. You'll see that the table includes both the cautious and optimistic boundaries. So given an overall attrition rate of 13%, the maximum allowable differential attrition rate is 6.1 percentage points under the cautious boundary and 10.8 percentage points under the optimistic boundary. Recall that the differential attrition rate from our example was 5.7, which is lower than the 6.1 cautious maximum. So this level of attrition would be low under both the cautious and optimistic boundaries. If an overall and differential attrition combination is allowable under the cautious boundary, then we know it also must be allowable under the optimistic boundary, because, by definition, the optimistic boundary allows for more attrition than the cautious boundary. Studies don't always report everything the WWC needs to complete a review. In these cases, the WWC often will ask authors to fill in any gaps. But authors don't always respond or have the information that the WWC needs. For example, a study might report the number of students who left the study, but not what condition they were assigned to. If so, the WWC can calculate an overall attrition rate, but not differential attrition. If the authors can't provide the missing information, the study still has a chance to demonstrate low attrition. To do this, reviewers can assume the worst-case scenario and find the highest differential attrition rate possible. So let's imagine a study examines two conditions, an intervention group and a comparison group. The reviewer could first assume that all of the attrition came from the intervention condition, and then calculate the differential attrition rate under that extreme scenario. Then, the reviewer could calculate differential attrition assuming all the attrition came from the comparison group. The reviewer would then choose the higher of the two differential attrition rates to use in determining whether attrition is high or low for the study. If the study has low attrition, even when using the highest possible differential attrition rate, then the WWC can be certain that the risk of bias from attrition is low. Knowledge check 3. A study randomly assigned 5,000 students to conditions, with 2,500 students in the intervention group and 2,500 students in the comparison group. The study team collected outcome data from 2,000 intervention group students and 2,400 comparison group students. Using the optimistic boundary, which level of attrition does the study have? Your response options are A. The WWC would consider this high attrition, or B. Low attrition. You may want to pause the video while you think about your answer. A is the correct answer. This study has high attrition. The overall attrition rate in this study is 12%. We calculate this as the number of participants who were lost to follow-up, or 600, divided by the original assigned sample size of 5,000. So, 600 divided by 5,000 equals 12%. We can then calculate differential attrition as the absolute value of the difference in the attrition rates in the intervention and comparison groups. The intervention group experienced a 20% attrition rate. The comparison group experienced a 4% attrition rate. So, the difference between 20 and 4 is equal to 16 percentage points. Using the table in the handbook, the maximum differential attrition is 10.9 percentage points under the optimistic boundary, when overall attrition is 12%. So, in this example, the study is deemed to have high attrition. Knowledge check 4. A study enrolls 20,000 youth and randomly assigns 15,000 of them to the intervention condition. The researchers collect immediate post-test data on 18,000 youth from 14,000 intervention group students and 4,000 comparison group students. The researchers collect 6-month follow-up data on 17,000 youth from 13,500 intervention group students and 3,500 comparison group students. For the 2-year follow-up, the researchers can afford to collect data from 10,000 youth. Which option for subsampling would not count as attrition? A. For the 2-year follow-up data collection, the researchers randomly select 7,500 of the 1,500 intervention group youth and 2,500 of the 5,000 comparison group youth. Or B. For the 2-year follow-up data collection, the researchers randomly select 7,500 intervention group youth and 2,500 comparison group youth who participated in the 6-month follow-up data collection. You may want to pause the video while you think about your answer. A is the correct answer. The WWC would not count the random subsample as attrition. The researchers collected a random subsample from the initial sample to follow-up. The WWC would assess attrition at the 2-year follow-up time point relative to the 10,000 youth selected in the random subsample. B is an incorrect answer because the WWC would count this non-random subsampling as attrition. The researchers proposed to select from among the youth who responded to the 6-month follow-up. The WWC would assess attrition at the 2-year follow-up time point relative to the 20,000 youth who originally went through random assignment.